Hi and Assalamualaikum. We are from Group 11. So, this is my team members. My name is Eka Elizabeth Muhammad Rozaini and my matrix number is B1224107884. Next, Hasha Hazira binti Ahmad Nazri B122410 521. Nur Humaira binti Abdul Rahim B122410 and lastly, Shalina Kamila binti Syahri B12240728. Introduction. The transfer function is an essential concept in control systems engineering and signal processing. It represents the mathematical relationship between a system's input and output, usually expressed in the frequency domain. It offers a clear and simplified way to describe how a system behaves, helping engineers to analyze and design systems using mathematical methods.
Assalamualaikum. My name is Hasha Hazira binti Ahmad Nazri. My matrix number is B12241051. So, here is the combination in a transfer function. So, the first is a gain K, second is a pole J omega or 0 J omega at the origin. The lastly is a simple pole 1 over 1 plus J omega over P or 0, 1 plus J omega. We are given the transfer function, which is the equation is Hj omega is equal to 5 bracket by J omega plus 2 over J omega multiplied by bracket J omega plus 10. This is my equation that we get is, first we simplify the each term that we got. For J omega plus 2 we factor out by 2, so we get the answer is J omega plus 2 is equal to 2 bracket 1 plus J omega over 2. And then the next step is for J omega plus 10 we factor out by 10, which is the answer is J omega plus 10 is equal to 10 bracket by 1 plus J omega over 10. Next, we substitute the answer that we get into the equation, and then we simplify the constant, which is the answer is 10 is bracket by 1 plus J omega over 2 over 10 J omega bracket 1 plus J omega 10. And then we cancel out by 10. The real answer is 1 plus J omega over 2 over J omega plus J omega 1 plus J omega over 10. And then the next step is for word plot. The first is the gain K is equal to 1. We use the formula 20 log 10 1 is equal to 0 dB. This represents a flat magnitude line at 0 dB. The graph will be the linear graph. Second is a simple 0. The term for 1 plus J omega over 2 introduce a 0 that causes the magnitude plot to start increasing at a slope of 20 dB decade beyond omega equal to 2. The third is a pole at origin. This gives a constant slope of negative 20 dB throughout the frequency range starting from the origin. And lastly is a simple pole. The term for 1 plus J omega over 10 adds another negative 20 dB slope starting at omega is equal to 10. This is a broad magnitude plot composed of multiplied by transfer function. So the first is we plot the gain. The blue line is a constant gain labeled as a K, which contribute a linear line at 0 dB. The second is a simple 0 for 1 J omega over 2. The graph will be up from 2, which is we can see the pink line on the graph is a simple 0. The third is a pole at the origin, which contribute a constant negative 20 dB slope starting from the lowest frequency. The graph will be stopped at 1 and down until 1000. And then lastly, the fourth is a simple pole. As you can see, the purple line is the simple pole. So the graph will be down from 0 and stop at 10 and will go down. For slope, from 1 to 10 radian, the net slope is negative 20 dB due to the pole at the origin. And then from 10 to 100 radian, the 0 at 10 radian cancel out the pole at the origin, resulting in a flat response. And then the third is beyond 100 radian, the simple pole adds another negative 20 dB, giving a net slope of 20 dB again. So now we have 3 slope at this graph. We find the resulting result for this magnitude graph. The first is we find the start point, which is 0 plus 0 plus 20 plus 0 is equal to 20. And then the first slope is 0 plus 0 plus negative 20 plus 0. The answer is negative 20. And then the second slope is 0 plus 20 plus negative 20 plus 0. The answer is 0. And then the lastly is the third slope, which is 0 plus 20 plus negative 20 plus negative 20, which is the answer is negative 20. And the result is here, which is we can see at the graph, the red line is resulting of magnitude graph.
Hi, my name is Shadina Kamilia binti Syahri. My matric number is P122410728. Today, I'll be presenting the both phase plot for 4 key components in our control system: gain, simple zero, pole at origin, and simple pole. This graph helps us understand how each element affects the phase angle of a system as frequency increase. I will explain each component one by one and how they contribute to the overall phase response and slope. First, gain K. The phase for constant gain K remains at 0 degree across all frequency, resulting in a flat line on the graph. Second, simple zero. For the simple zero, the phase begins to increase 1 decade before its break frequency and reach 90 degree, forming an upward slope. 3. Pole at origin. A pole at the origin contributes a constant phase shift of negative 90 degree throughout all frequency, shown as a flat line at negative 90 degree. Fourth, simple pole. The simple pole starts reducing the phase 1 decade before its break frequency and levels off at negative 90 degree, giving a downward slope. In both magnitude plot, the slope refers to how the gain in dB change with frequency log scale. Slope by each element in this graph has 3. First is simple zero. Slope calculation is 0 plus 0 plus 90 plus 0 equal to 90. After the zero frequency, the slope increased by positive 20, indicating a rising gain. Second, pole at origin. Slope calculation is 0 plus 90 plus 0 plus bracket negative 90 equal to 0. A pole at the origin starts the magnitude graph with a negative 20 slope from the start and continues indefinitely. Third, simple pole. The slope calculation is 0 plus 0 plus 0 plus negative 90 in bracket equal to negative 90. After the corner frequency of the plot, the slope decreased by negative 20, showing a falling gain. Both plot phase graph. For the gain K is H omega equal to 1 J omega divided by 2 plus 1 in bracket divided by J omega divided by 10 plus 1 in bracket. Second, simple zero. For the formula is 1 plus J omega divided by Z. First, 2 divided by 10 equal to 0.2. 2, 10 bracket 2 equal to 20. For 3, pole at origin, the formula is 1 divided by J omega. It has negative 90 Newton degree. for simple pole. Simple pole, the formula is 1 divided by 1 plus j omega divided by p. It has 3 plot, p over 10, p, 10 p. 10 over 10 equal to 1. Negative 90 Newton degree, 10 in bracket 10 equal to 100.
Next, I will explain how to obtain transfer function from block plot. So the block plot that I got is H. Firstly, as you can see from the graph, a straight line from 40 dB until 100, then decrease at 1000, then straight line. Next, we need to find K. So how do you want to find K? The formula to find K is 20 log 10, K equal to 40 dB, 40 per 20. So, you will get K equal to 10. K equal to 100. So, the final answer is 100. And the graph is decreasing, which means there is a simple pole at the frequency. Next, as you can see, the straight line is increasing at 1000, which means there is a 20 dB slope from the point. This indicates we can use simple zero at 1000. Second, find simple pole with slope at omega equal 100 radians per second. So the formula is 1 per 1 plus j omega per 100. Next, we need to identify zero with slope at omega equal to 1000 radians per second. So what is the formula? As you can see, the formula is 1 plus j omega per 1000. So we need to simplify, and we will get equal 10 in bracket j omega plus 1000 per j omega plus 100. And we need to change to s. So we will get h omega is equal to 10 s plus 1000 per s plus 100. This is the final answer for this question.
I want to explain about IC method. First, gain with slope using 20 log 10. Simple pole with slope at W equal to 100. 1 divided by 1 plus JW divided by 100 in bracket. Third, simple zero with slope at W equal to 1000 in bracket 1 plus j omega divided by 1000. So we can obtain the transfer function is 10 in bracket 1 plus j omega divided by 1000 divide 1 plus j omega divided by 100. Next, convert to standard form. When slope is decreased by negative 20 dB or decade, it is simple pole is present. Then, when slope is increased by positive 20 dB or decade, it is simple zero is present. How to find a value of K? 20 log K equal to 40. K equal to 10 multiply with 40 divided by 20 in bracket. So, the answer is 100.
So next for IC analysis, to obtain the transfer function from plot by analysis, the graph is straight line from 0 rad per second to 100 rad per second at 40 dB, so we can state that is the gain. Second, the graph from 100 rad per second is decreasing to 1000 rad per second, 20 dB, so we can state this simple zero with subtract 20 dB per decade. Then, the graph is straight line from 1000 rad per second to 10,000 rad per second at 20 dB because it is simple pole with at 20 dB per decade. So for discussion, the task was to examine a number of transfer functions and determine their respective magnitude but plots. A transfer function defines the response of a linear time invariant system as a function of the frequency of the input signal. By placing into standard form, obtaining its zeros and poles, and examining its behavior over a range of frequencies, we can sketch the Bort plot, a very important tool for analyzing system dynamics. For example, the slope of the Bort plot in decibels per decade indicates the presence of poles and zeros, which are each zero adds 20 dB per decade and each pole subtract 20 dB per decade. This allows the system structure to be easily inferred from the shape of the plot. Lastly, for conclusion, this problem focuses on the intrinsic connection between the transfer function of a circuit and its frequency domain behavior. As plotted on a bar plot, studying both assists us in identifying how systems scale or attenuate signals at various frequencies. This connection is significant in filter, amplifier, and control system design because it allows engineers to predict and specify system action effectively. The process of matching also facilitates better comprehension of how mathematical description of system map onto useful observable effect in signal processing.